Question 9. A car travels 16 miles per hour slower in a bad rainstorm than in sunny weather. The car travels the same distance in 3 hours in sunny weather as it does in 4 hours in rainy weather. Find the speed of the car in sunny weather. Okay, let's go get the time first, because let's see. The car travels the same distance 3 hours in sunny weather as it does in 4 hours of rainy weather. So rainstorm travels for 4 hours, and in sunny weather it travels for 3 hours. Okay, let's go talk about the rate. A car travels 16 miles per hour slower in rain than it does in sunny. So in sunny weather, if the rate is, say, X miles per hour, in the rain, 16 miles per hour slower is going to be X minus 16 miles per hour. Okay, remember that our distance equals what? Rate times time? So rate times time equals distance. So how far did we go in the rainstorm? We're going to do this rate, X minus 16, for 4 hours. In sunny weather, we've gone X miles per hour for 3 hours. Now, the car travels the same distance. This is what I'm zeroing in on. So these two distances have to be the same. X minus 16 times 4 has to be the same as X times 3. I'm going to distribute and get 4X minus 16 times 4, which is 64. And that's supposed to equal 3X. If I subtract 4X from both sides, I get negative 64 equals 3X minus 4X, which is just negative 1X. Dividing both sides by negative 1, I get X equals 64. Now, what was X? X was the rate in sunny weather. So sunny weather, I travel 64 miles per hour. And that's all at once. Cool. Question 10. Hazel and Emily fly from city A to city B. The flight from A to B is against the wind and takes 3 hours. The return flight with the wind takes 2.5 hours. If the wind speed is 26 miles per hour, find the speed of the plane in still air. Okie doke. Lots going on here. Here's city A and here's city B. We have wind. The flight from A to B is against the wind, so the wind is blowing this way, right? The wind is blowing how fast? 26 miles per hour. I'm going to go do my distance rate time chart. Distance equals rate times time. We've got against the wind, and we have with the wind. Okay, let's go do the times. Those are easy. The flight from A to B is against the wind. Against the wind takes 3 hours. The return flight with the wind takes 2.5 hours. Okay, here's the tricky part. You have this little airplane. All right, when it's flying this way, we don't know the speed of the plane. Let's let that be x. But it's flying against the wind. So if my plane was flying, say, 30 miles an hour this way, and the wind was blowing 26 miles an hour that way, it would really only be traveling, 30 minus 26? So 4 miles per hour. But what I want to get at is when you're going against the wind, it's going to be the plane minus the wind, miles per hour. And let me make that a little bit smaller. So I've got x minus 26 miles per hour. With the wind, it's going to be x plus 26 miles per hour. Now, distance is always rate times time. So this distance is rate, x minus 26 times 3. With the wind, rate times time is x plus 26 times 2.5. Now, I hope the distance between A to B and B to A is the same. So I'm going to set x minus 26 times 3, that's the distance against the wind, equal to the distance with the wind, which is x plus 26 times 2.5. Now I'm going to distribute. Distribute the 3, distribute the 2.5. I have 3x minus 26 times 3 is 78 equals 2.5x plus 26 times 2.5, which is 65. I'm going to add 78 to both sides, and I get 3x equals 2.5x plus, 65 plus 78, 143. I need to subtract 2.5x from both sides. Three x minus 2.5x is 0.5x, and that equals 143. Dividing both sides by 0.5, I get x equals 143 divided by 0.5, which is 286. So the speed of the plane with no wind would be 286 miles per hour. Question 11. Two cars are 316 miles apart, and they're traveling toward each other on the same road. They meet in 4 hours. One car is traveling 7 miles per hour faster than the other car. What is the speed of each car? Just to get an idea of what's happening, here's the road, and we know that this road is exactly 316 miles. Here's the first car, and here's the second car. And they're traveling towards each other. It takes them a total of 4 hours. Okay, let's go do our little chart. Okay, we're going to call this car A and this car B. They're a total of 316 miles apart. Let's leave that alone for a minute. They meet in 4 hours. One car is traveling 7.5 miles per hour faster than the other car. Since they meet in 4 hours, the time for both of them is going to be 4. You can keep the units if you want to. I usually write them just to remind myself. Okay, the time that they both travel is 4 hours. Let's go after the rate. One car, let's call that car A, is 7 miles per hour faster than car B. So if car B goes X miles per hour, car A is going to go X plus 7 miles per hour. Okay, what is the distance that car A travels? Distance equals rate times time. So X plus 7 times 4. What's the distance that B travels? X times 4. The total distance is 316. So the distance from car A plus the distance of car B is supposed to equal 316. What was the distance of car A? It was X plus 7 times 4. What was the distance from car B? It was X times 4. And you add those two distances up, you get 316. Let's go solve. Distributing the 4, 4 times X plus 4 times 7, which is 28, plus X times 4, I can write as 4X, equals 316. Collecting like terms, 4X plus 4X is 8X plus 28 equals 316. Subtract 28 from both sides. 8X equals 316 minus 28 is 288. Now divide both sides by 8. So X will equal 288 divided by 8, which is 36. Now, what was X? X was the rate of car B. So car B, how fast did they go again? 36 miles per hour. Car A travels 7 miles per hour faster. So what is 36 plus 7? It's 43. Car A travels 43 miles per hour. So the question says the slower car travels at 36 miles per hour. The faster car travels at 43 miles per hour. And that's it for another homework section.